Ever sat through a 2-hour presentation where the speaker seems to loop the exact same points over and over again? You check your watch, but they are making the same argument they made 40 minutes ago. There is an ancient Chinese proverb for this exact experience,言多必失, which translates to, "He who speaks much, errs much." When we see someone rambling on stage, we usually assume they didn't prepare enough, or maybe they are just tired and losing their train of thought. While those are common factors, there is a mathematical side to this that has nothing to do with how the speaker feels or how much they slept. Researchers at the Automation, Generation, and Information Science Lab recently tested this ancient proverb, and they did it using computer science. Their results showed that talking too much causes inevitable, mathematically proven systemic failure. It happens whether the words are coming from a person or a highly advanced AI. So, how exactly do scientists use math to prove a centuries-old saying about human speech? To figure out why we, and our computers, eventually start speaking nonsense, we have to look at the strict, invisible rules that govern how one word connects to the next. The scientists set up an experiment where a computer program generates text similar to word solitaire. The program looks at the words already played and uses them to guess the next word. To run a controlled version, researchers built this mathematical framework, known as Algorithm 1. The key rule is working memory. The system is only allowed to remember a strict, limited number of preceding characters to guess the next. They tested 2 different versions of this setup. The first was a low memory system, which could only remember the last 2 items. The second was a high memory system, which could remember the last 3. This setup perfectly isolates memory capacity as a single variable. It lets us answer a very specific question. Does simply having a better memory prevent you from talking nonsense? The researchers monitored 2 specific warning metrics, like dashboard dials. First is the semantic collapse rate, measuring when text gets stuck in an inescapable, endless loop. Second is vocabulary richness. If this dial drops, the language shrinks into poor, repetitive building blocks. For a speech to succeed, the collapse rate must stay low, and richness must stay high. The researchers designed this experiment to push both of those metrics to their breaking point. When generating short sentences, between 10 and 50 words, both the low memory and high memory systems performed perfectly. This graph tracks what happens as the output gets longer. At the 100-word mark, the low memory system begins failing with a 12% collapse rate. Stretched to a 500-word test, both systems spike uncontrollably, crashing into a near 60% collapse rate. At the exact same time, the vocabulary richness plunges off a cliff. For both systems, the diversity of the words drops from 100% down to a dismal 28%. The data is clear. Increasing the length makes failure a mathematical certainty. By the time we reach that 500-word milestone, errors and severely repetitive language become almost impossible to avoid. You might be thinking, if memory is the issue, why not just build a computer or train a person to have a much larger working memory? Looking back at the data, the high memory system did survive a little bit longer than the low memory one at the 100-word mark. The math shows that a better memory acts as a temporary buffer. It delays the logical avalanche, but it cannot stop the rocks from falling. This is a basic rule of probability. The longer a sequence of information becomes, the more errors pile up until they eventually overwhelm the original meaning. This explains why tools like ChatGPT sometimes generate bizarre hallucinations when you ask them to write incredibly long essays. At that length, the AI is simply hitting a mathematical limit. The information becomes so disordered that it's impossible for the system to stay on track. The same rule applies to us. Whether you are prompting an AI, writing a detailed report, or giving a stage presentation, fighting the math is a losing battle. Keep it short. The research confirms that staying brief is the most reliable way to ensure your message actually makes sense.